Hello. This podcast is on dynamics and the continuum. Faraday did not hold with action at a distance. He introduced the concept of a physical field to account for the interaction of electric forces across finite distances. In his paper, Speculation Touching Electric Conduction on the Nature of Matter, he points out that according to the atomic theory of matter, atoms were not considered as being in contact. Therefore, to account for the forces between particles, a role had to be given to the space between them. Faraday held that void space could not have causal or dispositional properties analogous to material bodies. Quote, "Mere space cannot act as matter acts," close quote. The agency of the interatomic void was inconceivable, and he concluded that the theory of atoms and void space should be rejected. In 1837, Faraday demonstrated that the induction of electric charges between bodies took place along curved lines, which he explained as a transmission of force through a dielectric medium surrounding the bodies. Faraday's lines of force, originally conceived as a heuristic device or symbolic of the alignment of charged particles, graduated to a metaphysical position. They represented the alignment of forces, and the objects or bodies referred to as particles were really centers of that force. His theory of matter is summarized by P.M. Harman in his book Metaphysics and Natural Philosophy. Quote, Faraday goes on to argue that all knowledge of matter was limited to ideas of the system of powers or forces in and around material substances, and he asserts that matter should not be envisaged as consisting of extended, impenetrable atoms surrounded by forces of attraction and repulsion, but that matter should be represented as a plenum of powers. He declares that the substance consists of the powers, maintaining that it was impossible to conceive matter independent of the powers. According to this theory, particles of matter were in reality centers of force. This theory of matter resolved the problem of explaining the mode of transmission of electrical forces, for matter will be continuous throughout, and in considering a mass of it, we have not to suppose a distinction between its atoms and any intervening space." End quote. Interactions in this continuum amount to exchanges between different concentrations of forces and their alignments. This resonates with vector calculus, where gradients, curls, sources and sinks transform the shapes and movement of the electrical or other continuous phenomena. Faraday was not a mathematician, and his theory, based on powerful philosophical intuition and imagination, had to wait for Maxwell to formalize in the famous equations. However, the equations on their own do not encapsulate Faraday's intuition of the oneness of nature. Newton's impenetrability and inertia of matter become derivative or secondary in Faraday's dynamical vision. He states, quote, "The mutual penetrability of matter depends upon the relative disposition of the powers, and matters as centers of power will therefore mutually penetrate to the very centers, like the conjunction of two sea waves of different velocities into one." Close quote. His analogy with the sea is edifying because he also envisages charge as simply a description of direction. Imagine a curved line of force A travelling in direction X and another B behind it travelling in the same direction. If both A and B are each considered part of two waves, then B will push A along or repel A. If A encounters a wave C travelling in the opposite direction, then they will conjoin or attract. This was illustrated in 1867 by P.G. Tate in his experiments with smoke rings, and is discussed in the previous podcast. Faraday believed that the propagation of forces could be caused by the vibrations in the lines of force. In this analysis, force becomes a byproduct or useful shorthand for waves, motion, vibration or frequency, and direction. The menagerie of particles and forces in the Standard Model have fallen into the same trap as the empiricists in the 18th century. namely of dividing matter up into primary and secondary qualities and then being at a loss as to how to fit them back together. It is the intellectual misstep of assuming that an abstraction which can help in analysis or mathematics has phenomenal reality or is an element of ontology. This results in false dichotomies which are impossible to later synthesize. To support the philosophical outlook of Faraday and Maxwell of analogies in nature revealing a consistent universal underpinning of all disparate phenomena, one can look at the transformation of all matter once heated to become some sort of fluid. Quoting from David Tong's lecture on theoretical physics, volume 4, on fluid mechanics, quote, "Take anything in the universe, throw it into a box and turn up the heat. Regardless of what you start with, the motion of this substance will be governed by the equations of fluid mechanics. When things get hot, everything looks the same. Take any element in the periodic table and heat it until it melts so that it is either a liquid or a gas. The motion of every element is governed by the same set of equations. The only reminder of what you started with is to be found in a handful of parameters of these equations which describe, among other things, the density and viscosity of the fluid. These will differ from element to element, but the basic set of equations are the same, regardless of whether you are working with an alkaline earth metal or an inert gas." Close quote. In addition to finding this unifying principle, it allows the physicist-philosopher to visualize structures in nature and helps form new intuitions. There are three interesting analyses that exemplify Faraday's intuition that there is only one substance and the variety of phenomena is accounted for by differential motion and concentration. Firstly, if the continuum involves, for example, the frequency of electromagnetic radiation, then the ranges from zero, representing darkness or silence, to approaching an infinite compression which takes the form of a solid object with too much mass to move as fast as radiation, but retaining inertia or persistence. The intermediary phases being gas and water, each phase becoming less viscous. Secondly, the periodic table has 118 elements, and of those by far the greatest is hydrogen. Not only does it account for 75% of all phenomena, but it is the building block out of which the others are constructed. Thirdly, emergent phenomena such as heat is produced by internal vibrations, and magnetism is an emergent phenomena as well, dependent on relative motion. For example, if a lab assistant were travelling through the lab at the same speed as an electric current, neither would experience magnetism. I believe all these notions have a connection with consciousness. Each individual consciousness experiences inertia, which is the apprehension of stability and persistence, while in reality it is sitting on a sphere, spinning at 460 meters per second and orbiting the Sun at 107,000 kilometers per hour, while the Sun is rotating at around 2.2 kilometers per second and travelling around the Milky Way with the rest of the solar system at just over 800,000 kilometers per hour. Our consciousness experiences nothing of this. We can only be the still point of this vast moving edifice if each individual consciousness is at its centre along the lines of Leibniz's monadology. The mechanics of a system of complexity through transformations in a continuum may be attainable, but leaves open the question of what exactly is the continuum. Is it a vacuum, ether, an electric field, a superfluid, or plasma? It is the age-old problem of substance. Physics can explain how the phenomena interact, but not what the phenomena is. The standard model is an infinite regression and will never solve this question. The other question, of course, is why anything exists at all, and there is a summary of Leibniz's answer to this question in the additional material accompanying this podcast. If you want to find out more, please visit my website at quantumid.science, where you will find more in-depth downloadable essays, book lists, additional material, and original papers by some 19th and 20th century physicists. I hope you've enjoyed these podcasts in tracking down the true identity of the quantum.